Why do columns buckle and how can we prevent it? Imagine stacking a tall stack of books and then pushing on the top. At some point, instead of just squishing down, the stack suddenly tilts and collapses. That's similar to what happens when a column buckles. Columns buckle when they are pushed with too much force that exceeds a certain point called the critical load. Instead of just compressing straight down, they bend sideways suddenly. This happens because the column loses its ability to stay straight and stable under pressure. The buckling isn't about the material breaking apart but about the shape becoming unstable. The main reason for buckling is that tiny imperfections or slight crookedness in the column can grow once the load gets high enough. Think of a thin straw. If it's just a little bent, pushing on it can make it bend even more until it snaps or buckles. When the load reaches the critical point, the internal bending moments caused by the tiny imperfections balance out the pushing force, making the straight shape unstable. The column then suddenly bends or deflects to the side. This behavior is explained by Euler's buckling theory. It says that the critical load depends on how stiff the material is, the shape of the cross-section, and how long the column is. The stiffer the material and the larger the cross-section's resistance to bending, the higher the load needed to cause buckling. Longer, thinner columns are more likely to buckle because their effective length is greater, making them less stable. How the ends of the column are supported also matters. Fixed ends can carry more load before buckling than pinned or free ends. To prevent buckling, engineers do a few things. First, they make the column stiffer by choosing materials with a higher modulus of elasticity or by increasing the size of the cross-section. For example, using a thicker steel tube or an I-beam shape helps resist bending. Second, they reduce the effective length by fixing the ends more securely or adding supports along the length. This shortens the column's span and makes it more stable. Adding braces or lateral supports along the column's length also helps prevent sideways movement. These supports act like anchors, stopping the column from bending too much. It's also important to control imperfections. During manufacturing and construction, avoiding crookedness or eccentric loads ensures the column stays as close to perfect as possible. Finally, engineers use safety factors and follow building codes. These standards include conservative load limits that account for uncertainties like material flaws or unexpected forces. Buckling is a sudden failure mode, so understanding how shape, material, and support conditions interact helps us design safer structures. In essence, columns buckle because under enough compression, their shape becomes unstable and they bend sideways. To stop this from happening, we make them stiffer, support them better, and keep imperfections to a minimum. Knowing these principles helps us build stronger, safer buildings and avoid unexpected collapses.